So here in this step was a small mistake. So while simplifying the left hand side, I had a y1 square. So I had 5y1 square. This was okay. Okay. And uh, regarding the power of y1, you had a 10y1 here plus 10y1, and you had a minus 8y1 here. That means this should be plus 2y1. Yeah, this was a mistake. And you have a 25 here and you have a 4 here. So this combines, you add them to make it 29. On the right hand side, you had plus 12 minus 12 cancelling. 4y square plus 5y square, y1 square would give you 5y1 square. So this was okay. And there was no y1 on the right hand side. Okay, so we simply had a y1 square and we had 36 plus 9, which was 45. Okay, now y1
Good
square
morning,
and
sir.
good morning. Now y1 square and y1 square again cancels off. So you get twice y1 is equal to 45 minus 29. That means twice y1. 45 minus 29 is 16. That means y1 is 16 by 2, which is equal to 8. So therefore we are getting the coordinates of, they were getting y1 as 8. And what was the original coordinates here? The original coordinate that we took here was twice y1 comma y1. So therefore what are the coordinates of p? Coordinates of p twice y1 comma y1, which is equal to p 2 into 8 comma 8, which is equal to p 16 comma 8. That's it. Okay, so this was about the last problem that I did. The small mistake I had made, and this has been corrected here. Okay, so let us now solve number 10. If you read the problem states that if the points A and B are on a circle with center C 2 comma 3, find the value of x. So let's draw a circle and take 2 points on the circle. So you have circle here. You have 2 points on the circle. The points A 4 3. So this point is on a circle. A 4 3. Another point on the circle is BX5. You can take any point here. Say BX5. Okay. Are on a circle with center C 2 3. Let's say center is C 2 3. Find the value of x. Okay. You need to find out the value of this in the B coordinate. You see an x in the abscissa. That is what you need to find out. Now this problem is very similar to the earlier problem. Why? Because see, if you join AC, you'll get a radii, right? And if you join BC, you'll also get a radii, right? So that means these two must be equal because they are the radii of the same circle. Therefore, distance AC must be equal to distance BC, and with the help of that, we can find out the value of x. Okay. So let us first find out the distance AC. Let us write down the coordinates first. Here A is 4 3 and C is 2 3. Therefore, what is AC? Write the formula first. Root over of x2 minus x1 whole square plus y2 minus y1 whole square. So take this one as your x1 y1, x2, y2. So you have x2 minus x1 whole square plus y2 minus y1 whole square. Okay, this is your distance AC. How much does it come to? 2 minus 4 is minus 2, and this is 0, 0 square. So this comes to root over of 4, which is 2. Okay, let us now find out the distance BC. So B here is x5 and C here is 2, 3. So therefore BC again equal to root over of x2 minus x1 square plus y2 minus y1 square. Square root of, consider this x1, y1, x2, y2. Okay, so put these values, x2 minus x1 square plus y2 minus y1 square. This is root over of 2 minus x whole square plus minus 2 square, which is root over of 2 minus x whole square plus 4. You've got the distance BC and you've also got the distance AC. So according to the problem, AC must be equal to BC because, give you a reason, because they are radii of the same circle. Because they are radii of the same circle. So now you put AC. Now you put the value of AC. How much have we got AC? AC we have got as 2. And how much have we have got BC? BC we have got as 2 minus x whole square plus 4. Okay. Now that means now in order to remove the radical, you square both sides. So squaring both sides, we get 2 square is equal to 2 minus x whole square plus 4. Right? If you square both sides, any confusion with this step? This step is a very important step which you will have to do in almost all the problems. So that is why be very clear with this step. Okay. So if you are squaring both sides, you are squaring the left hand side and you are moving the radical on the right hand side because you are squaring. So therefore 4 is equal to, and this is a square plus a minus b whole square, a square plus b square minus 2 into a into b plus 4. That means 4 and 4 actually cancel from these two sides. So what are you left with only? In fact, even if we don't expand, we'll get the value. Okay, we'll see. Let me do this here. So you have 0 is equal to 4 plus x square minus 4x. You're getting a quadratic. And when x square minus 4x plus 4 is equal to 0. Now this is again a perfect square. X square minus 4x, just as I have expanded here, okay, you can again write it as a perfect square. You can write this as a square minus 2 into a into b plus b square is equal to 0. Means x minus 2 whole square equal to 0. That means x minus 2 is equal to 0. That means x must be equal to 2. So that is the value of x. Otherwise, instead of expanding here, because what we have done here is we have expanded here and then again we have expressed it as a perfect square. Instead of doing all that, since we realize that 4 cancels, okay, see, instead of doing this, since we realize that 4 cancels on both sides, that means we are getting what? 0 is equal to 2 minus x whole square. That means we are getting 2 minus x is equal to 0. That means you are getting x is equal to 2. You can do directly from this step. This is a better way of doing. Okay. So we've got the value of x, which is 2. It was just like the previous problem, except the simplification was a little easier. Let us now move on to the next problem, number 14. In between, if you have any problem that you could not do, you can ask. Number 14. Question is, using distance formula, show that the points A, B, and C are collinear. Now, what do you mean by collinear? Collinear word means on the same straight line. So note, collinear means on the same straight line. This word collinear comes from two words, two English words, combination of two English words, co and linear. So co here means together and linear here means straight. So together on the same straight line. That is what it means. So collinear. You need to show that 3 points are collinear. So, okay, so let us write the points. The given points are A minus 5, 6, B. Oh, sorry. This is A is 3, 1. A is 3, 1. Coordinates of A. Coordinate of B is 6, 4. And the coordinate of C is 8, 6. 3 coordinates given. 3 points are there. So first, in such a problem, what you need to do is you need to first find out the distances. First, find out the distance AB. When you are finding out distance AB, just write down the coordinate first so that it is easier for you. So here A is 3, 1 and B is 6, 4. So therefore, what is AB? Take this as x1, y1, x2, y2. So root over of x2 minus x1 square plus y2 minus y1 square, which is root over of 6 minus 3 whole square plus 4 minus 1 whole square, which is equal to root over of 3 square plus 3 square, which is root over of 9 plus 9, which is root 18. Root 18 is a pure surd. Let us write it as a mixed surd. If you prime factorize 18, you will get 2 into 3 square, which is 3 root 2. Right? So this EB distance is how much? 3 root 2 units. Let us now proceed to calculate BC. P is 6, 4 and C is 8, 6. Therefore, BC is equal to square root x2 minus x1 square plus y2 minus y1 square. So which is root over of, consider this as your x1, y1, x2 y2. x2 minus x1, 8 minus 6 whole square plus 6 minus 4 whole square. Root over of 8 minus 6 is 2. 6 minus 4 is also 2. But this is root over of 4 plus 4, which is root 8. Which again, if you prime factorize, you'll get as root over of 2 cube. It can be written as root over of 2 square into 2, which is nothing but 2 into root 2 units. Okay, so once you have got the length of BC, you add up the lengths of AB and BC. Therefore, what is AB plus BC? AB plus BC is 3 root 2 plus 2 root 2, which is 5 root 2. Now, why am I doing this? I am doing this because I need to show that 3 points are collinear. Let us say that I suppose these 3 points are collinear. If these 3 points are collinear, then clearly your A, this is your point A, say, and say this is your point B, and say this is your point C. Then the length of this AB and the length of this AC, if you add up, that is why I've added. See, AB plus BC, AB plus BC, that is why I've added. Because if you add up the length of AB and BC, then you must get the length of AC. That is the idea behind this. So now what we do is we find out the length of AC, that is A and C, and check whether we are getting equal to AB plus BC or not, whether we are getting 5 root 2 or not. So let us check. So here point A is 3, 1, and the point C is 8, 6. Therefore, AC square root x2 minus x1 whole square plus y2 minus y1 whole square. Have your x1, y1, x2, y2. x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so this is root over of 8 minus 3 is 5. 6 minus 1 is also 5. The root over of 25 plus 25, which is root 50. And root 50, if you prime factorize, you will get this as 2 into 5 square, which is 5 root 2 units. So what you see here is, we see that AB plus BC is equal to AC is equal to 5 root 2. Okay, so what have we got here? We see that the sum of these two lengths is equal to this length. Therefore, we say that ABC must be collinear. Hence, A, B, and C are collinear points lying on the same straight line. Okay. Now, this is a very weak way actually to show that 3 points are collinear. Later, when we'll proceed in class 10, we'll see that there are much better ways of proving that 3 straight lines are collinear. This is using distance formula to prove 3 points are collinear is a very weak way of showing. Okay, but then this is the way of doing it. Number 16, very important problem. Number 16. Number 16. If you read number 16, the question is name the type of triangle formed by the points, and 3 coordinates are given. So the given points are, what do you mean by type of triangle?
Isosceles, equilateral.
Isosceles, equilateral, what else?
Scalene.
Scaling.
Right angle triangle. Isosceles right angle triangle.
Right, okay. Right angled, scalene, equilateral, isosceles. Broadly, these are the type of triangles. So, so the coordinates are A minus 5, 6, B minus 4, minus 2, and C 7, 5. These are three coordinates given. And you need to show that, and you need to, in fact, name the type of triangle that is formed, whether these three form an equilateral triangle, or whether they form an isosceles triangle, or whether they form a scalene triangle. So let us see what kind of a triangle is formed here. So in order to form the triangle, in order to see what kind of a triangle, you first calculate the length AB. So here A is minus 5, 6, B is minus 4, minus 2. So therefore AB, calculate the distance AB. That is length of the side AB of this triangle. X1, Y1, X2, Y2. Root over X2 minus X1, minus 4 minus of minus 5 square, plus Y2 minus Y1. That means minus 2 minus 6 square. So this becomes root over of minus 4 plus 5 square, plus minus 8 square. So this becomes root over of 5 minus 4 is 1. That becomes 1, and minus 8 square is 64. So this becomes root 65 units. And this is a pure surd, cannot be expressed as a mixed surd, because 65 cannot be prime factorized into can only be prime factorized as 13 into 5, both of which are prime. Okay, so root 65, we leave it as it is. Next, we calculate the distance BC. X2 minus X1, 7 minus of minus 4, because I've taken this as X1, Y1, X2, Y2 square, plus 5 Y2 minus Y1 whole square. Okay, this is root over of 7 plus 4 square, plus 5 plus 2 square. So this is root over of 11 square plus 7 square. So is root over of 121 plus 49. Okay. And 121 plus 49 is how much? 170. Right? That's it. So we have got the length of AC. Two sides we have got AB, BC. And the third side is AC. Let's find out the length of AC. So here, write the coordinates. A is minus 5, 6. And C is 75. Okay, so therefore AC is square root x2 minus x1 whole square plus y2 minus y1 whole square. So x1, y1, x2, y2. See, root over of x2 minus x1 whole square plus y2 minus y1 whole square. Root over of 7 plus 5, 12 square plus minus 1 square, which is square root 144 plus 1, which is square root 145. And can 145 be prime factorized? 145 it seems cannot be prime factorized. Okay, so therefore, yes, so what kind of a triangle is it?
Scalene.
It is a scalene triangle. Yes, yes, so let us write the length here. Here AB is, we have got it as square root 65 units. This should be units. This should be units. This should also be units. AB we have got root 65 units. EC we have got root 145 units, and BC you have got root 170 units. So what you see is that all the sides of this triangle are unequal. Okay, that makes it a scalene triangle. But remember, whenever you are attempting this kind of a problem where the type of triangle is asked, you also square the sides and check whether it is a right angle triangle or not. Okay, used by the converse of Pythagoras theorem, if you remember. So what you do here is you also check this, that AB square is 65, AC square is 145, and BC square is 170. Now if you add up AB square plus AC square, you get 65 plus 145, which is not equal to 170, right? That means it is not equal to, that means AB square plus AC square is not equal to BC square, right? We have added AB square and AC square. Also check AB square plus BC square is equal to 65 plus 170. Is it equal to 145? Yes, it's not equal to 145. That means AB square plus BC square is not equal to AC square. And AB square, AB and AC combination we have taken, AB and BC combination. Now AC square plus BC square. So AC square plus BC square is equal to 145 plus 170, which is also not equal to 65. That means AC square plus BC square is also not equal to AC square. AC plus BC, yes, not equal to AB. Yes. So that means, hence, triangle ABC is a scalene triangle, and which does not have a right angle also anywhere. because I have checked all three, and in none of these I got AB square plus AC square is equal to BC square, or AB square plus BC square is equal to AC square, or AC square plus BC square is equal to AB square. Now my question to you is that suppose if I had got AB square plus BC square, uh, AB square plus BC square is equal to AC square. Suppose if we had got this, suppose, then what could we say? We say that it is right angle, but which one is the right angle? In this case, what you could have done is you could have drawn right angle triangle. Could have drawn right angle triangle. A right angle is say here, and you could have guessed which angle should be your right angle. See, your AC is the hypotenuse here clearly. So this is your hypotenuse, AC. That means this is the only side that remains to be labeled. We label this as B. So which angle is right angled? That means angle B here is right angle. Understood? So in this case, we would have said, if this was the case, then we would have said that ABC is a right angle triangle. And in brackets, you could have wrote scaling. Even if you don't write scaling also, it's no problem. Because when you say right angle triangle, normally we mean scaling. We don't mean isosceles right angle triangle. Okay, for isosceles right angle, we mention specifically that it is an isosceles right angle triangle. So even if you don't mention the word scaling, even if you simply write a right angle triangle, that would have been sufficient. But figure is important. You have to draw the figure, and you name the coordinates also. The coordinates of A was given to be minus 5, 6. So you write the coordinates of minus 5, 6. The coordinates of B was given to be minus 4, minus 2. And the coordinates of C was given to be 7, 5. That's it. So after finding from the distance formula, after finding out the length, and after checking what kind of a triangle is, then only we draw the figure. Because when the coordinates are given, we are not sure which angle is right angled or which side is what. So only after finding out the length of the sides and after checking, then only you should draw the triangle. But drawing the triangle is important. Okay, so I stop here for today.